Hello, today we're going to look at the Nobel Prize in Chemistry in the year 1906, awarded to Henri Moissan. There's already been another video about the general information and the award ceremony speech. This time we go to the Nobel Prize lecture, but unfortunately Henri Moissan was not able to give a lecture because of ill health, and he died only a few weeks after he was awarded the prize. So instead of that lecture, we use here a article by Ferdinand I. Fechete on Ferdinand Frederic Henri Moissan, the first French Nobel Prize winner in chemistry, or nec pluribus impar, which means something like there was no one like him. I think that is a quote from King Louis XIV of France, if I remember it well. You can check that if you want. The article is summarized by me, and first we go into his life and life after death. On his return to civilian life, I've skipped a part here. Impressed by the mineral chemistry class of Professor Albert Rich at the School of Pharmacy, he selected, this is Moissan of course, this branch of chemistry as a field of research. In 1879, he reported his research in his thesis to obtain a first-class degree in pharmacy. His first extensive work in chemistry, when he started in Lille, addressed the family of iron oxides and had been proposed by Henri Debray, professor at the Sorbonne, and would be the subject of his doctoral thesis of science, which he defended in 1880. As a lecturer and head of practical work at the Paris School of Pharmacy since November 1880, he was appointed as an associate professor in 1882 with a thesis entitled Cyanogen Series. In 1887, Moissan became the holder of the professor's chair at the School of Pharmacy of Paris in toxicology, and starting from November 1899 in organic and mineral chemistry. He remained there until July 1900, when he was appointed to the inorganic chemistry chair of the Faculty of Paris, succeeding Louis Troost. There were two functions. In 1899, he was appointed the director of practice and industrial chemistry laboratory founded by Charles Friedel in 1896, and he replaced Charles Friedel, who had died. He held this position until his death in 1907. As a professor at the Sorbonne, he had more influence to reform the teaching procedures in the laboratory than he trained for analysis in industry, but he did not train engineers. Moissan wanted to raise the level and train engineers. In 1901, the laboratory became the Applied Chemistry Institute, and in 1906, he was allowed to deliver a chemical engineering degree. Education was accordingly reformed with a greater theoretical emphasis. The institute was named the National School of Chemistry of Paris, ENSCP, in 1984 and is currently ENSCP Paris Tech. Moissan also participated in the work of the Academy of Medicine and Health Council, the Aluminum Commission for the Ministry of War. Everyone who had the pleasure of being in his company said that he was a great pedagogue. He was appreciated for his teaching skills and his encouragement to young people. He wished that the students develop critical thinking, and he gave them freedom to express opinions contrary to his own. He brought cheerfulness and enthusiasm, and he communicated it to those around. His presence in the laboratory was a joy for all. As a prestigious researcher, Moissan was also an outstanding teacher who aroused many vocations and had numerous friends and foreign students. In 1882, he married Marie Leonie Lugan, the daughter of a pharmacist in the city. From this union, Henri Ferdinand was born, who was their only child. Henri Ferdinand became a chemist and pharmacist engineer, assistant to the School of Pharmacy, and second lieutenant of the Infantry Reserve, and he was killed in the war in the Meuse on 10th of August 1914. Then two research activities, primus inter pares, the first one is equals. His first studies, which were conducted at Dehran's lab, focused on oxygen absorption and carbon dioxide emission by plants that were kept in the dark. In 1874, he published his first results with Dehran. In 1878 and 1879, he published two other memoirs and his first-class pharmaceutical thesis. He abandoned plant physiology for inorganic chemistry. His first study in this area focused on oxides in the iron family, which was the subject of his doctoral thesis in science. The results led him to study various other metal oxides, particularly those of chromium, and he first discovered a method for obtaining perchromium in 1879. As early as 1883, Moissan had turned his effort towards fluorine isolation, and on the 26th of June 1886, he passed an electrical current through a solution of potassium fluoride in hydrofluoric acid in a platinum equipment. It cooled to minus 50 degrees Celsius to reduce the activity of fluoride. He isolated the gas in the platinum environment and obtained a pale yellow gas that degraded anything except plastic. It was the desired fluorine. Moissan also worked on the production of artificial diamond. Diamond synthesis was announced at the Academy of Sciences on the 6th of February 1893 and was fully confirmed a year later on, at 12th of February 1894. The experiments on diamond synthesis were achieved due to the use of very high temperatures. To achieve this synthesis, Moissan primarily considered the use of very high temperatures. Moissan invented the electric oven. He described this oven for the first time on the 12th of December 1892 in a note to the Academy of Sciences, and he constantly perfected it thereafter. Moissan obtained temperatures of approximately 3500 degrees of Celsius, where the highest temperatures that had previously been obtained did not exceed 2000 degrees of Celsius. With an intense source of energy, Moissan paved the way for a new and important chapter in organic chemistry, that of high temperatures. As a result, he could melt and crystallize certain metal oxides that were considered infusible, obtain some refractory metals in pure form and large quantities by reducing their carbon dioxides, and prepare often unknown metal carbides, nitrides, borides, silicides, distilled metals, and refractory materials. An important point of his work was obtaining calcium carbide, which paved the way for the chemistry of acetylene, which had two important applications at the time: gaslighting and oxyacetylene welding. Moreover, the preparation of pure calcium enabled him to study their properties and compounds, and obtaining calcium hydride led him to become interested in metal hydrides, which were a class of unknown compounds at the time. A later study by Moissan involved the isolation of the ammonium radical. His studies in this area were based on metal ammonium, and he thought to reduce the temperatures or use an electrolyzer, but he faced failures. However, by decomposing sodium amalgam at 80 degrees Celsius with a liquid ammonium oxide solution, the solid ammonium amalgam whose stage of purity you could study. He had promised to complete his study when death overtook him. The extension of Moissan's work remain important today both in the fields of fluorine and its inorganic and organic compounds, and in the high temperature and industrial diamond synthesis, where production is based on this principle of recrystallizing amorphous carbon at very high temperatures and very high pressures. In 1906, Moissan received the Nobel Prize in Chemistry for the isolation of fluorine in 1886 and the development of the electric furnace, which was described for the first time in 1892 and opened the path to high temperature chemistry. Moissan published more than 300 articles, books of notes, one on fluoride and one on the oven, and a mineral chemistry treatise in 5 volumes. Various brochures still describe his active participation in the university and academic life and the town planning problems in the city of Meaux, to which he always remained attached. In 1896 and 1902, Moissan became the president of the Chemical Society. elected vice president in 1907, he would have led a third time in 1908, but he died in early 1907. He was appointed a member of the Academy of Medicine in 1888 and a member of the Academy of Science in 1891. And in 1893, he was elected a member of the Pharmacy Society of Paris. He was a commander of the Legion of Honor and received many other French and foreign awards. Moissan had a special relationship with industry. The link between university and industry was one of his main concerns. Moissan, he was a fine man with a mischievous mood and was a great collector of paintings, works of art, and autographs. Moissan, with his encyclopedic spirit, wrote the comedy An Unexpected Marriage, which he proposed to the Odeon Theatre in November 1879, and on the 20th of February 1907, 2 months after receiving the prize, he died at the age of 54. The great respect expressed in these words not only pays tribute to the visionary scholar who has earned an honorable prize in history of science for eternal life, but also honors the man who loved the world and forged his star, which will continue to shine for centuries. The work of Moissan charms the soul of generations of chemists. Throughout his 54 years of existence, Moissan's Dignitatem showed how work was the code of his life. Dignitat is the honor of honors, if I have understood it well. Well, this was the article, shortly briefed by me. If you want to read the article again, follow the link, which also will be in the description under the video. So this as a substitution for the Nobel Prize lecture that Moissan was never able to give due to his untimely death. Thank you for watching, and maybe till another time. Next week we will go to the 1907 prize. Almost forgot these. Some illustrations. Here you see a photograph of the apparatus used by Moissan to discover fluorine, as you can see. And here you see a few of his drawings he put into his articles and books, also on the isolation of fluor. This is another one. I always particularly like those old illustrations, so I'm going to show you to them anyway, even it's a little bit after the end of the lecture, but for me it doesn't matter. Beautiful pictures. Again, thanks for watching, and maybe till another time.